Okay, what if I told you that everything you think is, well, solid and real is basically an illusion? I mean, what if the universe isn't made of things at all? What if it's just this huge, complicated dance of pure motion? Forget thinking about reality as a bunch of objects. Just for a few minutes, let's imagine it's a symphony. You know when a single drop of rain hits a perfectly still puddle? For just a second, you see these incredible, complex circles spreading out, crossing over each other, creating this beautiful, temporary pattern. And that right there, that's the perfect way to look at how motion theory sees the universe. It's not about the things themselves, the droplet or the water. It's about the patterns they make when they interact. Patterns that hold together just long enough for us to see them as something real. So, this whole idea that reality is really just about patterns, that's the bedrock of what we're going to call motion theory. Let's dive right into its one single central claim. And here it is. This is the core of it all. Everything is just structured motion. That's it. From the tiniest particle you can imagine to the light traveling from some super distant star. From a swirling hurricane to the actual thoughts firing in your brain right now, none of it is a static thing. They're more like self-sustaining rhythms. They're loops of activity, constantly balancing what comes in and what goes out just to hold their shape. Okay, so to really wrap our heads around this idea of a universe that's always in motion, we kind of need a new way to talk about it. The old words we use, words like mass and time, they're all tied up in this idea of a world full of static objects. Motion theory basically hands us a new dictionary, a way to redefine these fundamental concepts. First up, time. Let's just forget the idea of time as some universal river flowing for everyone. In this view, time is just a local rate. Think of it like the frame rate on a video. A pattern with a higher frame rate updates itself faster. It experiences more ticks of its own internal clock, compared to a slower pattern, even over the same amount of, our time. And what about gravity? It's not some mysterious pull, some invisible string yanking on things. In this view, gravity is simply convergence. It's the natural tendency for all motion to follow the path of least resistance. And where's that path? It's always toward areas that are more dense, more organized, more synchronized. So gravity isn't this weird force pulling us down, it's just the natural flow of motion. So if mass isn't stuff, then what is it? Well, it's a pattern's inertia. It's stubbornness, really. To be a little more precise, it's a measure of how much energy you need to change a pattern's existing motion. See? It's not a fundamental building block, it's just a property of the motion itself. And finally, energy. You can think of energy as the fuel that powers all these patterns of motion. It's the built-in potential for change inside a system. It's the budget a pattern has to either change itself or to go and influence the patterns all around it. All right, now that we've got our new dictionary, let's actually use it to rewrite the rules of reality. This is where this whole motion theory thing really starts to click. Let's start with a really basic question. If everything is always moving, how can something like a rock just be solid? Okay, imagine you pluck a violin string. It's vibrating like crazy, right? But it creates a stable, repeating shape that, to our eyes, looks like it's holding still. That's a standing wave. And that, according to motion theory, is exactly what a solid object is. It's just furious motion that's been trapped in a self-reinforcing rhythm. Okay, so if solid objects are really just trapped motion, what about the forces that act on them? Let's take another look at gravity. The classical view, the one we all learned, talks about this mysterious force acting over a distance. But motion theory sees it completely differently. It's not a pull, it's a path that motion just naturally follows. Picture a leaf that gets caught in a whirlpool. Is it being pulled to the center by some weird force? No, of course not. It's simply following the flow of the water. Well, that's gravity. Planets don't orbit the sun because they're being pulled on a leash. They're just following the curved pathways of motion that the sun's immense density has created in the space around it. So if gravity is just the flow of motion, what does that mean for mass? I mean, if it's not the stuff that's being pulled, then what on earth is it? Remember, mass is a measure of inertia, how much a pattern resists change. Think about a heavy weight on a spring. It bounces up and down more slowly because it's more stubborn about being retuned. It's the same idea. And get this, in an atom, most of the mass doesn't even come from the particles themselves. It comes from the insane amount of energy in the confined motion and the fields binding the whole thing together. Okay, so if mass is just a property of motion, that leads us to the biggest granddaddy concept of them all, time. Is it really this universal river we all imagine, flowing at the exact same rate for everyone everywhere? Motion theory says absolutely not. Your body, your brain, your entire experience of the world, it's all a unique pattern of motion, ticking away at its own specific rate. You know Einstein's famous time dilation? Well, in this view, that's just a synchronization lag between patterns that are moving at different speeds. There's no universal now. There's just this incredible symphony of countless individual rhythms, all playing at their own tempo. So this new way of thinking about time, mass, and gravity, it has some really profound implications. This isn't just a new way of looking at physics. It's a new way of looking at, well, everything, from the tiniest cell to the biggest galaxy cluster. And you really do see this idea of structured motion at every single scale. I mean, what is life itself? It's just a set of incredibly complex patterns from our DNA to our brains that have figured out how to remember and resynchronize themselves. What's a computer? It's just disciplined motion where we guide electrical currents with fixed rules to process information. And the entire cosmos, it's this grand dance between motion just drifting out in the voids and then converging into that great cosmic web of galaxies we see. This perspective offers a pretty fascinating way to reinterpret the history of science. Maybe, just maybe, physics didn't discover this whole zoo of different fundamental things like forces and fields. What if instead it just brilliantly observed and cataloged all these different patterns of motion, gave them labels, and then developed incredibly powerful math to describe how they behave? The math absolutely works, but maybe it's just the grammar describing one single subject, motion. So, where does all this leave us? Is motion theory the final answer to everything? Honestly, that's not really the point. The point is to offer you a new lens, a powerful new tool for your curiosity, a way to see the world just a little bit differently. So here's your invitation to become a motion theorist yourself. The next time you look at anything, a tree, a traffic jam, your own reflection in a window, don't just see things. Ask yourself two really simple questions. What is actually moving here? And what rule, what boundary is shaping that motion into this specific pattern? When you think you see an object, just try for a second to see the dynamic loop of activity that's keeping it going. The universe isn't some museum full of static exhibits. It's a symphony of motion. And you're not just a listener in the audience, you are part of the music. So, what song are you going to play?